سكر يطلع له فتحه من فوق من قدام لانه مايل لورا، يقوم حاطط مع دي سكر يروح عند الكوكاكولا في بلف من ورا زيه زي بتاع الزرع انه فصيل ولا انفار شاي ولا انفار حفر واخد بالك لانه سكر وسكر. نعم انا بقول مصنع يعني بياخد كميه من السكر. طبعا احنا عملنا كده تكلفه شويه وطالبين كانوا 140 قرش، السنه دي هيبقى بكام مش عارف، والبلاستيك اللي جواه ب 40 قرش، يبقى كل شويه في 160 قرش، 180 قرش، يبقى الطن بيكلف 18 جنيه. بعدها برجع ارميها تاني لمجرد ان احنا يعني. طبعا سكر الخام عمرهم ما يعرفوش شويه ضعف، برضه بتيجي لوالي تاخده او وحدات تاخده ثاني او يخزنه ثاني. عنبر السكر مفيش حاجه، مكان يطلع الانسان يرمي على الهوايه الساقيه سير يروح للمخزن من ذلك المختلط، او يطلع على علبه لها مسلوب من تحت يقوم دلقه فيه، يجي اللوري يقوم فاتح. اللوري هنا بقى مش مهم متغطي او يعني ممكن يبقى صندوق مفتوح، يفتح البلد يملاه سكر ويمدده له مع السكر. مفيش انفاق، مفيش حاجه ولا تدخل. لكن احنا لو طبعا بتيجي مراكز دي بتشيل 30,000 طن 40,000 طن، يروح السكر بالجواري على طول يقلب، فكان بيقلب او يعني يقلب الناس زي الالوان بتاعنا، وهناك يشطبه ويحط على كل الوزير في المسجد بدون اي عباده. احنا بنعمل كل السكرنا اللي حاطين. لو الوحدات بتيجي عندنا يعني مشغل هنا يمشي السكر زي ما هو كده كان عباره عن سير او عليه يمشي السكر يقوم لازم في قلب الوحده، وبعدين هو يقوم قافلها ومرصصها وبيطلع له عمليه يجي شفاط يشرب السكر ويجيبه بصومعه وعليها نعم زي الان لكن احنا بنرجع نعبيه شويه عشان نوزعه. طبعا لو العربيات كانت مهيئه زي ما بتكلم كنتش محتاج لاي حاجه من هذا الخلاف ولا ميكانيز ولا ميكانيز. يجي بقى السكر الابيض حسب الطلبيات اللي قدامه، اذا كان استخدامات كبيره من الدوالي، استخدامات محدوده بيعديه على طول كيلوات او يتحط في 30 5 كيلو 10 كيلو يطلع اوتوماتيك كده ورا بعضيه على التوزيع على طول. مفيش العكس اللي احنا بنعمله وده تمرين وده عقار وده معرفش ايه وكده. طبعا لازم بيشتغلوا بيحسبوا كل حاجه. احنا هنا في مصر غاويين نخلق صنع وبعدين نحكمه روتين مسؤولين عنه. احنا بنقول الكلام ده يعني بفتح ذهنكم لعل وعسى ان شاء الله لما تبقوا مكاننا يبقى عندكم فكره. طبعا هتعملوا حاجات احسن من كده بالمستقبل ان شاء الله. ودي فكره بسيطه وسريعه عن تطوير المعدات. طبيعي الناس هناك ما تلاقيش المصنع فيه حد وهو شغال، بيبقى اعداد محدوده جدا، ده بينعكس على التكلفه، وفي نفس الوقت محدش فاضي. انا شفت عنبر الناصبات الراجل قاعد خالف بيتين ودي محولين لثلاث نوع، ماسك مجله كده وقاعد يقرا وجنبيه خرطوم ملفوف كده على الورق. طبعا زي ما قلنا المناسيب بيتحكم فيها بلوك هواء، النافضات مع الشقه مع بعضيها دي تعدي وتتفرج، ما فيش سكر وهي قافله تحت بقر الشريط ده ماشيه واحده، في سكر تشتغل واحده واثنين وثلاثه حسب. فهو قاعد حصل شويه تلطشه كده من السكر وهو نازل، فراح ماسك خروجه راحت نازله في بلاعه، راح دايس على زر، راح في البتاع ده تعب هو. نعم طبعا احنا لو لازم نجيب بقى الناس تبلبط وتقلع الجلابيه والعمه وبعدين شويه جرادل وافتح خراطيم الحريقه واعمل معرفش ايه، مفيش الكلام ده اللي احنا بنتكلم. دي فكره بسيطه. طبعا تكون نتيجه انه يزودوا مرتبات الناس بتاعتهم تتحسن، وبعدين هم كمان في عمليات الصيانه ما بيعملوش الصيانه، هم يجي شركات عليها شركات عليها الاجهزه دي هي اللي بتعملها صيانه فقط تطابق مصنع شغل المريح لا الماسوره دي دارت ولا الماسوره دي ما استفدتش ولا يجيب حاجه. الكلام ده شركات المنتجه طبعا ده مش موجود عندنا في مصر، انما في البلد الجاي هي اللي بتيجي تعمل الصيانه. الصيانه يعني ايه؟ يعني رجع المعده لحالتها الاولى الجديده. هنتفرج دلوقتي على فيلم صغير ورينا عمليه الرمان ده هو الفيلم الثاني واستخدام الاعصاب.
This is the Panchito Gomez Toro sugarcane mill in Cuba. As in many other mills around the world, the Panchito Gomez Toro mill uses plain bearings in its stands. The disadvantages of plain bearings, however, are old and well known to people in the sugarcane mill industry. Plain bearings are both short-lived and energy-consuming. Bearings offer many advantages compared with plain bearings. The most important being their long service life, high load capacity, and big savings in energy. But despite all these advantages, rolling bearings have a poor reputation in sugarcane mills. It wasn't the fault of the bearings themselves. The problems lay in the seal design and the bearing lubrication. Consequently, SKF R&D has been trying for a long time to develop a seal and lubrication that will really work in sugarcane mills. Gunnar Bergling is the head of application engineering at SKF. Can you explain, Mr. Bergling, why rolling bearings aren't used in sugarcane mills?
Well, there is nothing new, of course, in using rolling bearings in sugarcane mills. They first appeared in the 1930s. This is the first mill provided with spherical roller bearings. The mill was built in India in 1934. At that time, there were high hopes that they would mean a real breakthrough in the industry. However, this didn't prove to be the case, as the service life of the bearings wasn't up to expectations, and as a result, these bearings have been put to little use in the past. The problem was to find a sealing design which would effectively keep out the aggressive sugarcane juice from the bearing. Another problem was to find an efficient lubricant.
Could you explain perhaps a little more about the problems concerning lubrication?
Until now, grease has been the only lubricant used for sugarcane mills, but grease has its shortcomings. One drawback is that grease isn't fluid, and therefore it is impossible to check it without pulling off the housing. Another drawback is that the particular greases used for the mills are so sticky. And they are sticky because of the very high base oil viscosity required. The stickiness, on the other hand, restricts the entry of the lubricant to the rolling element contact. And as a result, the oil film thickness is reduced and metallic contact and wear cannot be avoided. To counteract this, SKF has developed an entirely new lubrication method and combined this with a sealing arrangement that was first worked out in Australia.
Now, let's take a closer look at this development work by SKF. The new sealing and lubrication techniques were first tested here at the Panchito Gómez Toro sugarcane mill. Production started in November 1983. 6 months later, in May of 1984, after the bearings had been in operation for 150 working days, Gunnar Bergling made a trip to Cuba to remove the seals and see how the bearings had come through. Well, here the SKF team has begun to see some results. Now we'll see if the seal has remained tight. Yes, it looks clean and in good condition. No cane juice or dirt has reached the bearing. Let's see how the raceways look. They seem to have come through quite nicely. The surface shows no signs of wear, which means that the oil has performed fully in line with our predictions. As expected, it has achieved a complete separation between rollers and raceways. The SKF package solution is unique in that it combines a new sealing technique with an entirely new lubrication method. The results from the trial run in Cuba show that SKF R&D has found a rolling bearing solution that works. This marks a major breakthrough in the sugarcane industry in terms of lower energy consumption and reduced maintenance. In other words, increased productivity and profitability.
We opened the housings after 6 months of tough operation, and I was very satisfied to discover that the bearings and the seals more than lived up to expectations. The appearance of the raceways clearly indicated that an oil film had been built up and had completely separated rollers and raceways. All rubber seals, garter spring seals, as well as V-ring seals were in excellent condition. No wear worth mentioning was visible. Oil samples had been taken regularly during the whole period, and they proved that no sugar juice had penetrated the seals. The water content remained constant all the time. They could only measure the few hundredths of a % of water, which is always present in an oil.
In the Cuban mill, the SKF bearings were lubricated with a high viscosity mineral oil. Grease was only used for the seals themselves. There are two major advantages of using this particular oil instead of grease for the bearings. The first comes from the fact that the oil forms a thick film that completely separates rollers and raceways. Sticky grease, on the other hand, restricts the inflow of lubricant to the rolling contact, causing so-called starvation. This prevents the buildup of the necessary lubricating film. The second advantage with oil is that it is, of course, a fluid. This makes it possible to easily check whether contaminants have entered the bearing. As we see here, it's possible to sample the oil and check that the system is still tight, and this can be done at any time, without stopping the mill to remove the bearing. SKF supplies easy-to-use equipment for analyzing the oil. Grease, on the other hand, isn't a fluid, and it can't be checked without a shutdown to open up the bearing housings. Good lubrication ensures reliable bearing operation, long bearing life, and, in the final analysis, better profitability for the mill. Now, how does the spherical roller bearing work together with lubricant and seals? In the Cuban mill, the bearing had a 460mm bore and was mounted on a tapered seating. Mounting and dismounting was carried out by the oil injection method, and a hydraulic nut was used to drive up the bearing. All hydraulic equipment is supplied by SKF. Here you can see how a mounting is done in a similar application. Oil is injected to separate the mating surfaces. The hydraulic nut presses the bearing up its seating. When dismounting, oil is injected and the bearing slides off. Now we are going to take a closer look at the sealing arrangement. It's built up of an ingenious combination of various rubber seals and a labyrinth sealing that together effectively keep out the aggressive cane juices, bagasse and dirt. The contaminants are effectively prevented from entering the bearing housing. As we have seen earlier, the rolling bearing runs in a carefully sealed housing under ideal lubrication conditions. The seals are continuously re-lubricated with a standard lithium grease that helps keep out contaminants. In some cases, there is a need for a sealing system that can utilize the self-aligning capacity of the bearing to the full. This requirement can be met by this design. It represents an excellent solution for mills in which extra tilting capacity of the top roll is required. The new sealing design involves a combination of two supported lip seals and a labyrinth seal with an external removable V-ring seal. The seal lip has a conical backup plate to prevent deformation during assembly and during relubrication, which was a major problem in the earlier designs. A rubber V-ring seal at the entrance of the labyrinth seal serves as a first line of defense against the ingress of cane juice, bagasse or dirt. A worn V-ring can easily be replaced by vulcanizing a new ring in place. SKF supplies a standard tooling for this purpose too. Substituting rolling bearings for plain bearings reduces friction. Energy audits reveal savings in a rolling mill of around 25%. The results from Cuba confirm this figure. Let's put these figures in perspective. A 25% saving in a cane mill of the same size as the Cuban facility is equivalent to an annual saving of about 300,000 kilowatt-hours per mill stand for 3,000 operating hours a year. Such savings in power mean that the extra capital invested in rolling bearings will return a payoff in a short time, and even more so if the bagasse is used as raw material instead of being consumed as fuel in the production of power. An interesting application for bagasse as raw material can be found in the paper industry. When the cane crop has been processed, the procedure for mothballing the bearings until the next crop is very simple. The only work required involves draining off and checking the oil to see that everything is okay. If it is, then all you have to do is refill with new oil and a rust-inhibiting agent. You can then forget the bearings until it is time for the next crop. Then refill with fresh oil and start production. Correct service and the right preventive maintenance will assure you of getting reliable operation from your SKF rolling bearings for more than 20 crops. The marginal extra costs of investing in rolling bearings and seals will be compensated for by your short-term payoff. Rolling bearings also have a substantial advantage over plain bearings as regards load carrying capacity. They allow the rolls to operate at higher pressure and crush harder. SKF produces more than 500 million rolling bearings a year and is the world market leader. This is twice as many ball and roller bearings as the next biggest manufacturer. SKF know-how covers virtually everything there is to know about rolling bearings and their applications. This is knowledge from which the consumer can directly benefit anywhere in the world. If you specify SKF rolling bearings for all the rotating shafts in your mill,